Good morning, everyone. Today we're going to pick up where we left off. Now, if you want the note sheet, this is just the lower part of the note sheet from yesterday. And when we left off yesterday, we had been talking about how when you wanted to find the magnitude, or K, of a transformation, all you needed to do was divide a length in your image by a length in your pre-image. And that actually gives us a formula. And you can write this a couple different ways. For one, you can assign variables to these. I like to say that the length in my image is f, and the length in my pre-image is p. F for final image, p for, well, pre-image. And you can also, by the way, multiply both sides by p to get p times k is equal to f, or our pre-image length times our magnitude is going to give you your final image length. Now we did this formula already, but let's look at how this works when all we have to work with are pieces of information and some numbers rather than a picture. So we're told that S is a size transformation of 0.3. So we have here what we call a contraction. It is shrinking the original figure. If the triangle ABC has a perimeter of 70 centimeters, find the perimeter of the size change of 0.3 of that triangle. Now we know here that perimeter is length. Since I'm talking about length in regards to size change, I must be using these formulas. And it doesn't matter which one I pick, since they're the same formula written in two different ways. So I'm just going to go with this one, where my pre-image length times K is going to equal my final image length. Now I know that I want to find what my final perimeter is. That means I need to fill in P and I need to fill in K. According to this, K is our size change of 0.3. And my pre-image length that I'm talking about is the full perimeter, which is 70. So I actually have all of my information at that point, and I can do 70 times 0.3 is equal to our final image, or an answer of, well, I think it's 21. Let me just double check. Yep, answer is 21. And this is, of course, in centimeters. So we would be done. These ones are kind of nice because they're fairly straightforward. But like everything in geometry, we are going to try a little bit harder. And what we're going to talk about this time is enlarging a photo. So you started with an 8 by 10 picture, and you ended up with a 16 by 20. By the way, notice the order of this. The 16 and the 8 are corresponding lengths because they're placed in the same part. We're talking length times width. And I'm going to quick draw a sketch of this because, like usual in geometry, if I can find formulas and sketches, they just help you piece it together and make it a little bit more reasonable. So I'm going to call this 8 by 10, which means this one I need to start with the bottom here at 16 by 20. So those lengths still correspond, 8, 16, 10, 20. Okay, and we have a person in the enlarged photo. This is the image, by the way, versus the pre-image, the small one, the one I started with. The person in the enlarged photo, my image, is going to be 9 inches tall. So I'm going to draw a wonderful and super detailed person over there, and you guys can decide who that is. Hopefully not me. And this guy is 9, or girl, is 9 inches tall. How tall were they in this picture? Well, let's look at the details. I know when I'm talking about length or height and size change, I'm using the formula pre-image times magnitude is equal to the final image length. And here, I know the final image length to be 9. But I do not know my size change. It hasn't told me my size change. And I also don't know the starting length. In fact, this is ultimately what I want to find. So I know I won't be able to fill this in because that would be my final answer. So there should be enough information to find K. So how can I find K? Well, I can find K by remembering that any lengths can be used to find magnitude. In other words, if I can find any two corresponding lengths between my original and my final, I can do this one divided by this one to get k. So here, since 10 turned into a length of 20, that means that my image length of 20 divided by my pre-image length of 10 will give me k. And 20 divided by 10 gives me a k of 2. Now if you can, you should always double check this. That's saying that I took my original and I doubled it. And here I can see that 8 turned into 16. So 8 times my k should give me 16, and we said that k was 2. 8 times 2 does equal 16, so that makes sense. Now that I know what k is, I can fill it into my formula. So I end up with the formula p times 2 is equal to 9. Divide both sides by 2, and you get p is equal to 4.5. And we're talking about inches here, so this person right here should be 4.5 inches. Those concepts can also get applied to the equation of a circle. So let's take that formula that we used in the last unit, where x minus h squared plus y minus k quantity squared is equal to r squared. And h and k are the center of the circle, in this case 2, -1, and r is equal to the radius of the circle. Or in this case, if I were to draw in my radius, it's going to give me a radius of 4, just the distance from this point to a point on the circle. So what I'm going to do is I'm going to quick fill in that information into my size transformation, and I'm going to draw a line first on here so that I can give my general formula in a second. I'm going to start with the original formula for my example, so we can see what happens to this when we do a size change on it. So here my original formula was x minus our center of the circle squared plus y minus our center of the circle squared is equal to r squared. So we ended up with y minus, or x minus 2 plus y plus 1, that negative, remember, changes that to a positive, and our radius is 4. Okay, so now let's do a size change, and let's just do a size change like we would normally do a size change. The center of my transformation is 0, 0. That means every point that used to be this far away is going to get changed by whatever magnitude I pick. And let's do a size change of 3. So if this used to be 2 units over and 1 unit down, it's now going to be 3 times as far over and 3 times as far down, giving us 2 turning into a 6 over, 3 times as much, and a -1 turning into a -3, or 3 times as much as before. And that gives us our new point of 6, -3. So our center has moved here, and you can even double check, they should still be on the same line. You can see expanding out to this point. Now, I could try to move every point in the circle, but that's going to get really messy. I know that all I need to draw a circle is the center and its radius. So I used to have a radius of 4, but this is now 3 times as large as it used to be. So instead of being 4, that original length, I'm actually going to have a radius of 3 times 4. So a radius of, 3 times 4, which is 12. And that brings me all the way out from the point 6 to the point 18. At this point, since I now have 4 times my magnitude of 3, or 12, I can draw in my circle and get my final answer. Now this is going to give me a circle, slightly off here, but a circle that looks like that. There we go. Okay, so let's write our new equation, and I'm going to try to do the multiplication that I did in order to get this answer in how I write my middle answer. So when I'm doing this size change, this is going to help me find a formula so I know what's going on. I know that my original equation is still x minus something plus y minus something, or in this case plus something. is equal to my radius something squared. In order to get the 6, I did my size change times my original of 2. And here, again, I did my size change times my original, which was -1. I just moved the negative out front. And here I had my original of 4, and I just multiplied it by my size change of 3 to get that new radius of 12, so 3 times 4. And that does give me my new equation of a line. But better yet, not only does it give me a new equation of a line of x minus 6 squared plus y minus, or plus 3 squared is equal to 12 squared, I have actually found out how to write all equations of the circle with a size change of a magnitude k and our original formula of the circle. Now notice this does have to have a center of 0, 0 because we're expanding away from 0, 0. If this is the case, what you're going to get is we're going to start with our x minus h squared, and all I'm going to do is multiply by k, our size change. And I'm going to make this a really big K, and we'll see why in just a second. Then I'm going to do y minus our little k, or our k that is the y coordinate. And I'm going to, of course, multiply that by my magnitude of k, which is the size transformation. And last but not least, that's going to be equal to our radius times k squared. Please watch the order here. You have to multiply the r by the k before you square it. In this formula, I multiplied the 3 times the 4 and then squared it, and I got 12. If I had taken 4 squared times my k, which would have been 16 times my k of 3, well, 16 times 3 is not 144. In fact, it's quite a bit smaller. It'd be 48. So that would have given me the wrong formula. So just make sure you have parentheses around your k times r before you square it. Okay, so that's going to be our formula for how to find the equation of a circle. And let's do that right here. We want to find the equation of a circle with a center of 2, -1 and a radius of 4. Now the original equation looks like this. X minus 2. Oh, that's the same one that we just did. Let's find a new one. Let's do an equation where we have x minus 7 squared plus y minus 3 squared is equal to 2 squared. And I want to do a magnitude of, let's go with 5. We're going to do a magnitude of 5. So all I need to do is take every number in here and multiply by 5 before I square it. So k multiplied by each of the things I normally fill into my formula. And that gives me x minus 7 times 5, which is 35 squared, plus y minus 3 times 5, or 15 squared, is equal to 2 times 5, or 10 squared. Again, it does matter that you multiply by the 2 before you square it. This could also give us 100 if you want to write it that way. Now, the second question is what happens when we do this transformation and it has the same center as the center of the circle here. Well, let's say I wanted to do a transformation of this circle where it is, 2 times as big, but has the same center of size transformation as the center itself. So its center is 2, -1. Well, in this case, that means that this point would not go anywhere. My original point would go nowhere because my original point is the center of transformation, so it is 0 away. In fact, the only thing that changes is how far I go out. So if I was going with a radius of 4 and I am doing a size transformation of 2, I'm now going to go twice as far, or I'm going to go to a radius of 8, which brings me all the way over here. And that way I can draw in my circle, not having to move the center, since the only thing that's